Hello, everybody. Good morning, good afternoon, and good evening. My name is Mohammed Bakir, and I'm currently a master's student in chemical engineering, presently in my first year. My research is entitled Friction Reducers in the Industry. And before I discuss with you my research, I'm going to discuss with you a problem which I'm sure you've all faced, whether you're driving your vehicles to work or school, whether it's in lubrication, using oil, whether it's in firefighting, oil recovery, or irrigation. All these processes in the real life industry have one common problem. This problem is called friction. And a common example, which I'm going to be discussing in friction, is in fracking, which I'll illustrate in the next slide. So here in fracking, you mix large amounts of water at high flow rates and high pressure, mixed with other additives such as sand and chemicals, to inject a fracture deep down on the ground to recover oil with large amounts. One additive in fracking, known as or slick water fracking, is referred to as a friction reducer, which I've illustrated here, which is a commonly used one in industry, is referred to as polyacrylamide, which is chosen because of its low cost, environmental friendliness, and its ability to reduce friction by over 80% using very, very, very small amounts in large water. And overall, I hope that this research is going to reduce energy consumption and water consumption of fracking, as well as to reduce the cost of fracking. Here's a typical curve of friction reduction in a flow loop setting, which I'll be doing my research in, where this is one of my experiments where I mixed a small amount of polymer with water at very high flow rates to reduce friction by over 80% here. And as you can see here, that there's a peak, but due to the salts in water and the high flow rates, the polymer decays over time, as it can be shown here. And my research here plans to use a novel additive, a brand new additive, which has been rarely ever used, to improve this decay by making it decay less and to improve friction performance. And overall, in the long run, this will help reduce the low cost in fracking, and not just fracking, I'm talking about many other applications, whether it's in oil recovery, whether it's in lubrication, whether you're driving your car. This has potential to be done in many other applications just by using this one additive mixed with a polymer to reduce friction, high flow rates using very, very small amounts, and reduce the amount of polymer that's actually used in the fracking water. So imagine very small additives in large water, reducing friction, making it more stable. This is where I'm coming to play. So you don't like friction, remember here, talk to me, I'm your guy. I'm going to reduce friction, save you costs. And if you have any questions, don't be shy to ask. So thank you all for taking time to listen. And before I'd like to conclude, here are my acknowledgements for University of Calgary and Schulich for giving me this platform, as well as the NSERC for sponsoring this project, and my supervisor, Dr. Nashat Nassar, and my research group for giving me any feedback, insight, helping me with understanding the topic and the research. So remember, guys, if you have any questions, don't be shy to ask, because as the saying goes, as from some of my professors, the only stupid question is the one that you don't ask. So if you have any questions, do not hesitate to ask. Thank you very much. Have yourselves a good day, evening, or afternoon, wherever you all are. Peace out.